The shell basics. The shell is the default working environment for a Linux administrator. It is the command interpreter in any Linux operating system. The shell is a program that executes other programs. It provides a computer user an interface to the Linux operating system so that the user can run different commands or tools with some input data. When the shell has finished executing a program, it sends an output to the user on the screen, which is the standard output device. For this reason, it is referred to as the command interpreter. The shell is much more than just a command interpreter. It is also a programming language of its own, with complete programming language constructs such as conditional execution, loops, variables, functions, and many more. That's why the GNU Linux shell is more powerful compared to the Windows shell. Different shells for Linux are available, but Bash is the common shell. So when we are talking about the shell in this course, we are talking about the Bash shell. Bash stands for Born Again Shell, and it is the default shell on many Linux distributions today. It is also a Bourne shell compatible shell, and offers practical improvements over the Bourne shell for programming and interactive use, which includes command line editing, job control, unlimited size command history, shell functions and aliases, unlimited size indexed arrays, integer arithmetic in any base from 2 to 64. Commands entered at the shell prompt have three basic parts: command to run, options to adjust the behavior of the command, arguments which are typically targets of the command. The command is the name of the program to run. It may be followed by one or more options which adjust the behavior of the command or what it will do. Options normally start with one or two dashes to distinguish them from arguments. Commands may also be followed by one or more arguments, which often indicate a target that the command should operate on. The shell makes a difference between three kinds of commands: aliases, internal commands, and external commands. A shell alias is a shortcut to reference a command. It can be used to avoid typing long commands. For command patterns, it can reduce keystrokes and improve efficiency. A simple example is setting default options on commands to avoid having to type them each time a command is run. Some aliases are provided by default. Type alias on the command line to get an overview. To define an alias, use alias, new command, =, old command. As in the default alias, ll equal ls -l -color equal utu. Note that aliases are executed before anything else. Second, Bash built-in commands, also known as internal commands, are part of the shell itself. Each built-in command is executed directly in the shell itself, instead of an external programs which the Bash would load and run. You can show the list of built-in commands using the help command. An example of internal or built-in command is alias command, while the top command is an example of the external command. To find out whether a given command is an internal built-in or external, you can use the type command. For example, type -a cd type dash A top. The $path is an environmental variable in Linux and other Unix-like operating systems that tells the shell which directories the executable programs are located when a user enters a command. To find out which exact command the shell will be using, you can use the which command. For instance, type which ls. To find out where the shell will get the ls command from, you can use the echo command to show the contents of the $path variable by typing echo $path, which reads the current value of the path variable and prints that on the standard output. Also, you can get an overview of the current variables defined in your shell environment by typing the env command. When you want the system to execute a command, you rarely have to give the full path to that command. For example, we know that the ls command is in the /bin directory. You can check with which ls. Yet, we don't have to enter the command /bin/ls for the computer to list the content of the current directory. The path environment variable takes care of this. This variable lists those directories in the system where executable files can be found, and thus saves the user a lot of typing and memorizing locations of commands. So, the path naturally contains a lot of directories containing bin somewhere in their names. To check, type echo $path. As soon as match is found, the search is stopped, even if not every directory in the path has been searched. If you use programs in other directories more frequently, you can change your path to look in your directories. For example, to add your /home/downloads directory, we can use the export command. Export path equal, we will enter the old path data, followed by colon /home/downloads. Then press enter. Note that here changes are not permanent. When using the export command in a shell, the changes are temporary and only valid for this session. Opening new sessions, even while the current one is still running, will not result in a new path in the new session. To make it permanent, you need to add the export path command to your home/mu/.profile file or home/mu/.bashrc file. For example, to add home/downloads to the path variable in the home/mu/.bashrc file, here I will use the nano editor to open the .bashrc file for editing. nano.bashrc. Press enter. And at the end of this file, add export path equal $path colon /home/downloads. Here I put $path to keep the old path as it is, or it will be removed and you will only see the /home/downloads path. Press Ctrl X, then press Y to confirm saving, and press enter to confirm using the same name and exit. Note that this will not automatically update your path for the remainder of the session. To do this, you should run source the path to .bashrc file or .bashrc file if you are in the same directory, and press enter. Let's check. Echo $path. Note that for the root user, you will do the same steps but on the /etc/profile file or the /etc/bashrc file. Environment configuration files. When a user logs in, an environment is created for that user automatically. This happens based on 4 different files, where some script code can be specified and where variables can be defined for use by one specific user. /etc/profile file. This is the generic file that is processed by all users upon login. /etc/bashrc file. This file is processed when subshells are started. User home directory /bash_profile file. In the user home directory, in this file, user-specific login shell variables can be defined. And .bashrc file. In the user home directory, in this user-specific file, subshell variables can be defined. In these files, a difference is made between a login shell and a subshell. A login shell is the first shell that is opened for a user after the user has logged in. From the login shell, a user may run scripts which will start a subshell of that login shell. Using /etc/motd file and /etc/issue file. Bash offers an option to include messages in the /etc/motd and the /etc/issue files. Messages in the /etc/motd display after a user has successfully logged into a shell. Notice that users in a graphical environment don't see its contents after a graphical login. Using /etc/motd can be a convenient way for system administrators to inform users. Another way to send information to users is by using /etc/issue file. The contents of this file display before the user logs in. This provides an excellent means of specifying specific login instructions to users who aren't logged in yet using text user interface. For example, nano /etc/issue. Add some data. Press Ctrl X. Then press Y to confirm saving and press enter to confirm using the same name and exit. Now press Ctrl Alt F3. As you can see, the data I have entered is appearing up. I hope this has been informative for you and I'd like to thank you for viewing.